Hey guys, welcome back to our exponential unit for Algebra 1 students. So today we're going to be giving you an introduction to radicals and rational exponents. Now, we're not going to be talking about this very much. That's more of an advanced Algebra 2 topic, but there is a pretty simple rule involved with rational exponents. But first, we need to talk about radicals and how they're evaluated. So, a radical can be anything that involves, this symbol right here. Notice that's a square root symbol. That means if you were to put a number here, then we would be finding the number in which we would find. Then we would find the number in which, if we square it, we get 4 as our answer. Now, the square roots are not the only kind of roots out there. There could also be third roots, fourth roots, fifth roots, sixth roots, seventh roots, eighth roots, ninth roots, 10th roots. All kinds of roots that you can have here. Okay? There's all kinds of stuff you can do. Now, each nth root has its own specific rule. So, we're going to talk a little bit about it. So, there are 4 rules that we're going to need to know. First, I need this double. Oh, it's already double spaced. First, if n is odd, then there is one real nth root. For example, we have cube root of 27. There is one real nth root. So what number can we cube to get this answer? It's 3, right? Right. Now this can work on negative numbers as well. Say like we have cube root of negative 64. What's the nth root of that? And that correct answer should be negative 4. If you know that 4 cubed is 64, and that 4. So here's an idea. Remember back in middle school when you were talking about integers? Here's a rule that you can follow. If you have an even number set of integers that are negative, or there are no zero and negative integers to multiply, then your product will be positive. And if you have an odd number of negatives, then the product will be negative as well. And since we're multiplying 3 negative numbers, you'll get negative 64, and that's why there is one real nth root of a. Okay? Pretty simple. Now, even number roots are a little bit more complex. Okay? So if n is even, and a, which stands for the number inside the square root, the radicand, I'm going to put quotations here, and a is positive, then there are 2 real nth roots. So what this means, here's what I mean. So here's what I mean. We all know the square root of 64, right? We can say it's 8, but we gotta say something else as well. It's 8 and negative 8. Remember the rules again. It's going to be an even number in a negative number, so we're multiplying. And so negative 8 times negative 8 equals, also equals 64. That's why we have two real nth roots here. Let's try a little bit more, something more complex. How about fourth root of 81? Test out a few numbers, test out a few integers, and see which numbers multiply into 81. If you guess 3 and negative 3, then you are correct. So the thing to remember is that the real nth roots of this kind of situation, roots for this kind of situation, is always an integer. It's always a number and its opposite. All right. This one you should think. This one should be a little bit easy. Should be really easy to understand though. If n is even and a is 0, then there is one real nth root. So why is it easy? Think about it. If you were to take square root, take square root, cube root, fourth root, fifth root, whatever kind of root, square something root of 0, your answer is always going. I do not want to delete that. Your answer is always going to be 0. It's always going to be that easy. Easy, because if you multiply, because you have 0 in anything in a multiplication problem, your answer is 0. Alright, now for the last rule. If n is even and a is 0, then there are no real nth roots. So here's an example of where this occurs. You got square root of negative 2. What is the answer to that? No real nth roots. Because you can't because remember the rule, you cannot multiply the same number twice to get a negative number. You have a positive and positive, negative and negative. Both situations are always going to be positive. Can't get a negative number. Instead, you get something called imaginary numbers, which we're going to be talking about in the Algebra 2 topics. Alright, let's break it down. And I mean page break. Alright, so now let's talk about the rational exponent stuff. So what do radicals and rational exponents have in common? Well, let's say that you have a little something like this. What is this? You have x to the power of 1/2. What does that mean? What does that mean? Well, let's think. What is that? The power of a fraction a over b. Let's take x to the power of a fraction a over b. So what does that mean? Well, there is a pretty good way to simplify this. We can end up with the b root of x raised to the power of a. So if you have x to the power of a over b, you can pretty much make x a root, and make sure it's b, not a, and then whatever you get is your result raised to the power of a. So here's an example. You have 4 you have 4 to the power of 1/2, right? Alright, so using this rule, what can you figure out about 4 to the power of 1/2? Well, as you can see, your b value is going to be 2. So we can use, so you can write this, but it's kind of informal. So you got square root of 4 raised to the power of 1. I'm not going to write it out because, well, it's power to the 1. But the square root of 4 is 2. Alright? Now, let's try this. Eight to the power of 2/3. What is that? Well, let's convert it to radical form first. So, as you can see, our b value is 3, so it's going to be cube root. Our base is 8, so that is our radicand. And then we take this entire thing and raise it to the power of a, and our a value is 2. Alright, now we simplify the cube root. So it's going to be 2 squared, which equals 4. And that's it, guys. It's pretty easy stuff. Alright? So, not going to talk about it as much for the rest of Algebra 1, but once we get to Algebra 2, it's going to get it's going to be used a whole lot more, okay? But anyways, thanks so much for watching, guys. Be sure to leave a like, subscribe, and tell your friends about the videos I've been making, and thank you so much. Again, have a great rest of your day. We're going to be talking about exponential functions tomorrow, so see you there.